Hello, this video is to help you with Indiana Wesleyan Math 108 Quiz Help Workshop 2. All right, all these problems are simulated from your quiz. First one, convert 10 years to hours. All right, so what we're going to do is we're going to write 10 years here. I'm going to write a little field goal system. You may use one or all. You may need more. And I'm putting what I desire to get over here, and I desire to get hours. So I have years and I need to convert to hours. I don't know how many hours are in a year. If you do, you can just do one conversion. But I do know that I have 365 days in 1 year. So now I have years in the numerator, years in the denominator, so those will cancel each other out because they're dividing the same unit. So I have days and I'm trying to get to hours. So I still don't have my desired unit, so I have to say, okay, I do know how many hours in a day. So there's 24 hours in 1 day, so days cancel out. And now I have my desired unit, which is hours. So to do this, everything on the numerator gets multiplied and everything divides the product of the denominator. So I have 10 times 365 times 24 divided by 1 times 1. So if I go ahead and do that out, I get an answer of 87,600 hours. All right, number 2. How much will a person pay for 3.5 pounds of bananas at $1.55 per pound? So this here, we have 3.5 pounds, and I have times $1.55 per pound. Whenever it says per, that means divided by. So pound or LBS is the same thing. And if you notice, again, my pounds cancel out, and then I am left with dollars. And if I go ahead and multiply that, I end up getting $5.43. And it also asks you what unit, and that is also dollars. Okay. Number 3, convert the measurement into units specified. And so I have pounds into kilograms. So if you notice, I have already circled over here the pounds to kilogram conversion. So I'm going to set up again 17 pounds. And I only need 1 because it gives me a direct conversion. I have 1 pound and I have 0.4536 kilograms. And I'm wanting kilograms. So I have 17 times 0.4536. And it's going to be divided by just 1. You don't have to put divided by 1 because when you divide it by 1, it doesn't change your answer. So my answer then will be 7.71 kilograms. Okay. Number 4. Suppose you run from your friend's house. So here you are, and you're running to your friend's house, and you're running at 6 miles per hour. And then you're kind of tired, so on the way home, you're going to go back and you're going to run at 3 miles per hour. Now, it's the same distance, so now we're just going to answer the questions that it asks us to answer. The first one says, how long did you spend running? Okay, so rate times time equals distance. What is my rate in the first one? My rate is how fast I'm going. So I'm going 6 miles per hour. My time, I don't know. That's what the question's asking, so I keep that as a T. My distance, it tells me it's 3 miles. This distance from home to here is 3 miles. So I just say that equals 3 miles. Okay, so I'm going to divide both sides by 6 miles per hour. So those will cancel out. And I'm going to divide this 6 miles per hour. So what happens is my miles end up canceling out and I end up having an hour. And I end up getting 3 over 6 miles, or excuse me, 3 over 6 hours, which is 1/2 an hour, or 30 minutes. All right, the next question asks, how long did you spend walking? So walking is the same setup, except instead of 6 miles an hour, we're going to change that to 3. So instead of here, we're going to divide by 3. So my 6's all here just end up changing to 3 because I am walking now at a 3 mile an hour rate. So now this becomes a 3, and now 3 divided by 3 is 1 hour. So running took me 1/2 an hour, walking took me 1 hour. Okay, now it says, is it true that the average speed of a 6 mile an hour trip and a 3 mile an hour trip, which is 4.5 miles an hour, on the same distance? Well, it's tempting to say yes. However, we have to look at how long we've actually been running and walking. And since I spent less time running, I only spent half an hour running and I spent an hour walking, then that's not my average rate of me moving. So the answer would be no, because there's less time spent. All right. The next one asks us to find the average speed. Okay, so let's go ahead and look at this. When I was running, I went 6 miles an hour, and I went for 1/2 an hour, right? When I was walking, I went 3 miles an hour, and I went for 1 hour. So what we're going to do is we're going to find the average. So we're going to add those up, and what do we divide by? Well, how much total time did I spend moving? I spent 1.5 hours moving. So if I add this up, 6 times 1/2 is going to get me 3, plus 3 times 1 is going to be 3, divided by 1.5. So I get 6 divided by 1.5, and that gets me 4. So my average time moving was 4 miles an hour. Okay. Number 5. If your car gets 29 miles per gallon, how much does it cost to drive when you have 360 miles when your gasoline costs $3.20 per gallon? Okay, so if you have 360 miles, the first part of the question basically you need to find is how many gallons of gas are you going to need if you're getting 29 miles per gallon? So you're getting 29 miles per gallon. Then, when you get this answer here, and that tells you how many gallons of gas you need, you're going to take that and you say, okay, that's how many gallons of gas I need, times $3.20 per gallon, and that's going to get you your total cost of the trip, which comes out to be $39.72. All right, number 6. A hose fills a hot tub at a rate of $3.58 gallons per minute. How many hours will it take to do a 335-gallon hot tub? So this gives me a per minute, and I have to do per hour. So I'm going to go ahead and say, well, I have a 335-gallon hot tub, and I know that I can do it at 3.58 gallons per minute. And this, remember, is going to give me per minute rate. And so when I find this out, I divide that out, you get 93.57 gallons per minute. But remember, the answer asked me to put it in hours, so I'm going to convert this gallons per minute, and I want it in gallons per hour. So my gallons are okay. Those units are okay. It's just the minutes I need to change to hours. So I know that I have 60 minutes in 1 hour, so I'm going to divide this by 60 minutes. And that's going to get me my 1.56 gallons per hour. Number 7. Okay, if you take a 46-second walk from the first floor to the third floor, so from first floor to the third floor, you are traveling 2 floors, because that's the second floor. So it took you 46 seconds. So it took you 46 seconds for 2 floors. So how much did you take you to travel 1 floor? Obviously divide that by 2. So it takes you 23 seconds to travel 1 floor. Okay, so it's asking how long is it going to take you to go from the first floor to the 6th floor at the same pace, assuming the same height. So from the first floor, if I, just so I make it here, if this is my first floor, 2nd, 3rd, 4th, 5th, 6th, if you notice, I go up 1, 2, 3, 4, 5. So I go up 5 floors to get to floor 6. So I need to take my 23 seconds. That took me 23. 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 So I need to take my 23 seconds and multiply it by 5, and that's going to get me my answer of 115 seconds. Okay, final problem. Number 8. This one just asks you which shampoo is better. You have one at $3.59 for a 14-ounce bottle, and one, or excuse me, for a 6-ounce bottle, and one for $11.69 for a 14-ounce bottle. So I'm going to go ahead and show you how I got this one here. So I took the first shampoo bottle at $3.59 and I divided it by 6 ounces to get me at 60 cents an ounce. The second bottle of shampoo was $11.69 divided by 14 ounces to get me 84 cents an ounce. So clearly this one is the better buy. All right, thank you very much. If you need any other help, please email me.